And it's not humans who can make inventions. Our cousins, orangutans, can also make clever inventions. Implanting human genes in plants. Isn't interesting? Scientists have successfully implanted a human gene in plants. Indian scientists develop a technology for water reuse at lower cost. Let's see more of these interesting stories from the world of science and technology. I'm Nidhi Kumar and you're watching Science Time, a show that brings to you the best that science offers, from exciting developments in science and technology to futuristic solutions. Let's get started. Let's move on to story number 1. And chimpanzees have long been thought to be the only non-human great apes to regularly smash nuts with stones or wooden hammers, one of the most complex forms of tools used and observed in nature. Now, researchers have found that orangutans too can use hammers to crack open nuts, and they learn to do so without copying others. So Elisa Bandini at the University of Tübingen in Germany and her colleagues observed 12 zoo-dwelling orangutans that were given hard nuts and small wooden logs as potential hammers. None of the animals had previously broken nuts open with tools. But some of the apes never tried the potential tools, but most wielded the logs as hammers to crack open the nuts, and 3 used a tree stump or another object as an anvil to stabilize the nuts. 4 animals started to use the tools without observing more experienced individuals, which suggests that orangutans can spontaneously learn to use objects as efficient nut crackers, the researchers say. And with that, let's move on to story number 2. And have you ever imagined that we can insert human genes in plants? A study published in the journal Nature Biotechnology reports an unusual experiment Chinese and American researchers have been doing. And the researchers have been studying the effects of the human FTO, fat mass and obesity associated protein, also known as alpha ketoglutarate dependent dioxygenase enzyme, gene, and the protein it encodes. For years, they have tested what happens when the gene is planted in plants, and the results show that the combination has been successful. And Zhuang Ho, a professor at the University of Chicago, and Qifang Jia, a researcher at the Peking University, wanted to know if the protein had such a special effect on the human and animal body. And the same would apply to plants that do not otherwise have FTO. However, there was a chance that the plants, because they did not recognize the protein, would react negatively to the foreign substance and become ill or die. Quite interestingly, the result of the study in turn refuted the ideas and brought surprising success. The plants, instead of being damaged, yielded twice as much fruit as before, and the researchers said that this was possible precisely because their bodies did not recognize the protein and therefore could not keep it under the usual strict control. So the FTO was free to exert its effects. The rice, which was tested under laboratory conditions, yielded 3 times the yield, and the plants grown in the open also doubled in weight and yield. And potatoes also became more robust, and similar changes were observed for all other varieties. According to the researchers, in the future, the modification may contribute to the development of very beneficial properties, as not only increased yield but also root length. Treated subjects were more photosynthesized and more tolerant of water, scarcity and stress. And this is a feature that may be much needed in regions with less ideal climates, especially the fact that more and more people have to support agricultural areas due to population growth, and the expected extreme weather events and more frequent droughts can have a detrimental effect on planted crops. And let's move on to story number 3. Well, the Energy and Resources Institute, New Delhi, has developed a new advanced oxidation technology which uses UV-Photocatalysis to treat municipal sewage and highly polluting industrial wastewater streams for reuse at a much lower cost. The Advanced Oxidation Technology, or TADOX, can reduce dependence and load on biological and tertiary treatment systems and help achieve zero liquid discharge (ZLD). It can bring down capital expenditure on zero liquid discharge by 25 to 30% and operating expense by 30 to 40% for industrial wastewater treatment. According to information provided by the Ministry of Science and Environment, the technology involves UV-Photocatalysis as an advanced oxidation process at the secondary treatment stage, leading to oxidative degradation and mineralization of targeted pollutants. It improves biodegradability, thereby preventing biofouling of membranes and enhancing lifespan and efficiency of RO systems, as also overall load on evaporators like multiple effect evaporators and mechanical vapor recompression. It can reduce chemical oxygen demand, biological oxygen demand, dissolved organics, pathogens, persistent organic pollutants, and micropollutants. And TADOX could be integrated and retrofitted in existing treatment systems, making it a viable option as a novel decentralized wastewater treatment technology applicable in upcoming and existing infrastructural projects, townships, commercial complexes, green buildings, and smart cities. And with this, we come to an end of this edition of Science Time. We'll be back with more interesting stories from the world of science next week. Stay tuned to India Science. Keep watching every Friday at 9 p.m. Namaskar.